Number 5, let a of x equal x over 2x plus 1 and b of x equals 1 over x minus 4. So again, this video is on composition of functions and specifically rationals here. So the first thing we want to set out to do is just track what our domain of a and b is, and then we will take a look at the restrictions for our composition. So we cannot have, you guys know how to do this, go ahead and just do it if you want, but we can't have a 0 in the denominator, obviously, right? So we would have 2x plus 1 not equal to 0, and that'll come out to be x not equal to negative a half for that one. So it's anything but that. That's for a of x domain. And then the domain of b of x, we can just kind of do in our head that we can't have x equal to 4, so x not equal to 4. So we've tracked that. One of the things we want to do is figure out this composition a of b of x. So what we're going to do is take b of x and we're going to plug it right in there, and everywhere we see x in the a of x function, which I'm writing right now, x over 2x plus 1, we're going to take that 1 over x minus 4 and plug it in. So if I rewrite this like so, 1 over x minus 4 inside there, then that kind of might look similar to your algebra of functions that you were working with earlier. Whoops. So now I'm going to do that kind of off to the side here. So we'll have a of b of x is going to equal 1 over x minus 4. So I'm plugging in for this x here. Okay. Then I want to have 2 times 1 over x minus 4. So I'm plugging in for this x right there, plus 1. So now I've made my composite. However, it's a complex fraction and we need to simplify this. So usually people get this part okay, but then we need to do that thing where we clear fractions within fractions, and that sometimes gets tricky. So that's a skill that you've learned. Go ahead and try it and then see how you do. Okay, so I'm going to put a little classwork is pause and simplify. And then I'll talk about the domain. I will go through it in live motion, but go ahead and pause just so you can try it. Okay, so hopefully that went okay. What we're going to need to do here is look at the common denominator is x minus 4. So we want to multiply this entire expression here by x minus 4 over x minus 4. We're clearing a complex rational, so it's kind of like multiplying by 1. And then we're going to distribute this to every term. Okay, so I'm going to write it out carefully so you can see what's happening. So then we have 1 over x minus 4 in the top times x minus 4. And then we have 2 over x minus 4. I'm just multiplying that numerator there, x minus 4. And that's also times the x minus 4 from here. And then I have my plus 1, which I also have to multiply by that x minus 4. So even though this is not a fraction, don't forget to do that one. Then we have some cancellations that will happen, which is really nice. So, and I should actually put like parentheses around that just to be sure. And those will reduce out, which works out great for me. And then I have 1 in the numerator and 2 plus x minus 4 because I'm just distributing a 1. So 2 plus x minus 4, and then reduce that, or just calculate out 2 minus 4 there, x minus 2. So this is my a of b of x. So we have to think about what the domain is. So running out of space here. Sorry, I'm writing really big so you guys can see it. So I'm just gonna, wipe this out for a sec, this one. Get that out of my way. So the domain is going to be, the inside function is b of x. So my domain will have to be the restriction for b of x. So that's going to be x not equal to -4. We also can't have a 2 there, right? Because if I have a 2 down here in my composite function, then that's going to cause trouble. So those are my restrictions so far. Oops, I don't know why I wrote -4. That should be a 4, +4 on both accounts there. Let's fix that. Good thing I got that. It's just looking at the minus, I guess. So those are 2 restrictions. The other thing we want to check is if we have a situation where b of x, so b of x cannot ever equal the restriction for the a of x. So b of x can't equal -1/2. Let's set that equal and see what happens here. So we have 1 over x minus 4, and we don't want that to equal -1/2. Okay, so I'm going to pause and you can work that out, and I'll work it out also. Okay, so we have worked this out. I get x can't equal 2, which is the same as what I have down here for my composite. When I have the a of b of x, the domain for that is also x not equal to 2. So that will work out just fine. So typically you don't have to do all this extra work. You can do that at first to double check, but as long as it works in your composite, it should be fine. And then the way we would write that domain is going to be here. Domain would be x not equal to 2 or 4. Okay? And 4 should be. So just separate that by commas, not nor. It's just, it can't be either one. So, and then I don't think we talk about range in this one yet anyway. So that's it for a of b of x. Now I want you to try as classwork the one that I erased there. So I'm going to get rid of this so you can see that again. Like stuff I wrote. And you are going to find b of a of x and determine its domain. So pause the video and I'll rewrite this stuff a little smaller so it fits. Okay, so we have b of x over 2x plus 1, because that's the a of x function, and I went and plugged it right in here. Normally this was just an x, but the way I wrote it before in the other problem, I just want to be careful that you're clear that you actually have to plug in there. So now we need to simplify, and to do that we can do a couple of different things. You might try, but clearing the denominator works well here. So we're going to go ahead and multiply by every term by the 2x plus 1. Here I wrote it out the long way, like with showing you how it distributes and everything, but just make sure you multiply every term by 2x plus 1 in both the numerator and denominator, and then these will reduce. So then my goal again is to have just nothing in the no extra fractions within fractions. Okay, so that comes out to be 2x plus 1 all divided by this x minus 4 times 2x plus 1. And then that can simplify down to be 2x plus 1 over negative 7x minus 4. I just have to distribute this and then calculate. So this is my b of a of x, my final answer. I have to look at the domain of the inner function, the a of x. So domain is going to be all real numbers, or x is an element of all real numbers, such that x is not equal to negative a half. And we also have to figure out what the domain of this is. So we can't have negative 7x minus 4 equals 0. So the restriction there is also x cannot equal negative 4/7. And you can figure that out the way we did up here too if you want to, but don't worry about that. This will cover it. So these are my answers here. To get that full question done. All right, and that is a long enough video, so I'm going to do the next one with the radical and a quadratic. That's tricky to find the domain too, so we'll take a look at that in a separate video, and then I'll do the word problems here, or the one word problem, and then these kind of puzzle type problems in another video.